Power is work done over time, the rate at which work is done. The units of power are watts, so a watt is, from this, a joule per second. We also write work is power times time. What you pay for at your house is not power. What you pay for at your house is power times time. So if you look at your bill, you're billed for kilowatt hours, watts times time, because that's the amount of work that the electricity did in your home. That's what you actually used. You're not paying for things you're not using. And if you want to know what a horsepower is, it's 746 watts. So power is energy over time. You pay for power. Energy is power times time. Again, right? Energy supplied over time. Exactly what we've talked about already. We convert food into energy. I talk about this a lot because it's an important part. You can tell food is important to me. It's an important part of what we do. In there are a couple of different things. There's the work we do. So the work I do, talking and moving around and things like that. There's thermal energy, right? The heat I put out, thermal energy, and then I can store some of that and clearly have stored some of that in fat, right? So we eat our food and it gets distributed around all these different things we do, right? The energy our body uses, which is the thermal energy we're talking about here, that's our basal metabolic rate. It's really important if you are concerned about your weight, understanding what your basal metabolic rate is and how it comes about. So just a quick review or a quick look at this in the terms of where we're using energy in different parts of our body, and a typical human runs at about 85 watts. All right, that's a typical basal metabolic rate. You're putting out about 85 watts per person. Now, if you think about that in terms of a lecture hall and you've got 100 people in there, right? That means you have over 8,000 watts of heat you have to deal with in that lecture hall. And so the heat of the human body is really important when it comes to designing systems and designing air conditioning. If you want to look at how much energy is in a gram of fat, right? 1 gram of that fat is 39,000 joules. And we got earlier 8 million joules is about a daily consumption of food. So 1 gram is a pretty big chunk of that. If you eat 1 Big Mac, that's 33 grams of fat. I would have to climb 106 stories in a building to burn that off if we don't take into account my basal metabolic rate. Now my basal metabolic rate makes an enormous difference in that and drops that 166 down to probably like 40. Still a lot of stairs to burn off a Big Mac.